Welcome to the problem section for 2.1, right angle trigonometry. And we're going to do quite a number of exercises, so let's get started. The first one is going to say, use the given information to find the 6 trigonometric functions of the angle A. So we have a triangle where B equals 3, C equals 5, and A is not given. Let's see if we need it. In fact, for the very first one, sine of angle A, we of course need the side A because that's the opposite. It's an easy Pythagorean triangle, so C equals 5, B equals 3, A is going to be 4 because 5 squared minus 3 squared is 16, take the square root is 4. So sine A is then the opposite, divide by the hypotenuse, so 4/5, or of course 0.8. Cosecant of the angle A is the reciprocal of sine A, so it's going to be 5/4, or 1.25. Cosine A is the adjacent divided by the hypotenuse, 3/5, or 0.6. Secant A is the reciprocal of that, so 5/3, or 1.67. Tangent A is the opposite over the adjacent, so it's going to be 4/3, or 1.33. And cotangent A is the reciprocal of that, 3/4, or 0.75. That's all that's to it. I could do this on a calculator, but this will suffice. Let's do the next exercise. I'm not going to push that as far as that. Here it says, in this right triangle, find sine, cosine, tangent, sine, and so on. So all of them again. What do we have given? The opposite for the angle A is 5, and that's supposed to be a lowercase a. C is given as 6, and B is to be calculated as, well, let's see, 6 squared minus 5 squared is 11. Take the square root of 11. So we're coming up with 3.31. And then sine A is 5/6, which is, I do this on the side on my calculator, 0.83. Cosine A is going to be 3.31 divided by 6, which comes out to, looks like 0.55 rounded. That's good enough. And tangent A is going to be 5 divided by 3.31 equals, and I do that on the calculator on the side, 1.51. At that point, I'm going to double check with the solutions in the book, and the first one that I did a moment ago was indeed correct, and this one here so far, yep, square root of 11/6, and so on. Okay, sine B. Notice that this is the angle up here. So here we have to look at what is opposite and what is adjacent. For sine B, the side down here is the opposite, so the 3.31, and this one here is the adjacent. So when I determine sine B, it's going to be 3.31 divided by 6. But I already did that a moment ago for the cosine A. And cosine is going to be the adjacent divided by the opposite, so 5/6, which is 0.83. And is going to be 3.31 divided by 5, which is 0.66, I believe. I better double check that on my calculator rather than doing it in my head. Let's see, 3.31 divided by 5. This one was, here we go, yep, 0.66 rounded. How come cosine B equals 0.83, which is the same as sine A equals 0.83? Well, that's a cofunction theorem. Angle B and angle A go together as complement angles, so sine A is the same as cosine B, and cosine A is the same as sine B. We'll see that in a few exercises down the road. Okay, let's get going to the next exercise. Here what we're supposed to do is, in this diagram, angle A is in standard position. Find the coordinates of point B and then find sine A, cosine A, and tangent A. So the coordinates of point B, this is to scale, are 4 in the x and 3 in the y. So it's going to be 4, 3. That means the tangent we have right away because it's the opposite over the adjacent. So it's going to be 4 divided by 3, or 1.33. Cosine, well, we would have to determine what the hypotenuse is. Well, with these easy coordinates of 3 and 4, the hypotenuse, of course, is going to be 5 according to Pythagorean. So the cosine is going to be 4 divided by 5.8. And the sine is going to be 3 divided by 5.6. Again, I double check here with the book that I did it correctly, and that's exactly what the book came up with. In the next exercise, in fact, we do come across the cofunction theorem, where it says, use the cofunction theorem to fill in the blanks so that each expression becomes a true statement. So sine of 10 degrees is the same as cosine of 80 degrees because that's the complement angle. And I also made myself a printout, so I'm going to write this down. Sine 10 degrees equals cosine 80 degrees. Cosine 40 degrees is the same as sine 50 degrees. Tangent 8 degrees is the same as cotangent 82 degrees. And cotangent 12 degrees is the same as tangent 78 degrees. Here, what I said is we're going to use the graphing calculator, which I actually have to open first. So give me a moment. I forgot to do that prior to the session. Let's see that I truly find it here. I hope this is not going to take away too much time. Okay. Okay, there's the graphing calculator. I'm going to go to the home screen. I did something prior to this here. I'm going to type in sine 10 degrees and see what I come up with. Negative 0.544. You may not recognize it, but I know that's actually wrong. Watch what happens. Cosine 80 degrees, right? Should be the same, and it's definitely not the same. You have to be careful what kind of degree mode you're in. So click on mode and notice we're on radians, which will be introduced in the next chapter. We have to be in degrees. So if something funky happens that it doesn't turn out, double check if you're in radians or degrees. So switch to degrees here, go back to the home screen, do it again, sine 10 degrees. Should be relatively close to 0, and it's in first quadrant, so it should be a little bit above 0, 0.1 maybe. Oh, there you go, 0.17. Cosine 80 degrees. It's relatively close to 90 degrees, so it should be rather small as well. Of course, we know the solution because we rely on the cofunction theorem. It's going to be 0.17. 0.73. There it is. So that's indeed correct. The other ones, of course, are going to be cosine 40 degrees. That's close to 0.7 because close to cosine 45 degrees, which is square root of 2 over 2. Yep, 0.76. And sine 50 degrees, of course, the same. Then the third one was tangent of 8 degrees. That's relatively close to 0. 0.14. Notice that the graphic calculator allows me to close the parentheses or not, but that's only at the end. Otherwise, it's better to always close the parentheses. Cotangent 82 degrees. Well, it does. The calculator doesn't have the cotangent function, so I have to use the tangent anyway. So here's what I'm going to do. I'm going to do 1 divided by tangent of 82 degrees. And there we go, 1.40, just like the other one. And then cotangent of 12 degrees, respectively. I can save myself a little bit of work and do second entry and change this here to 12 degrees. Oops. 12 degrees. There we go, 4.70. And then I do tangent of 78 degrees. And I come up with 4.70. That's, of course, what we had expected. Okay, I'm going to go back to Word. Let's see. There we go. So, checked on the graphing calculator. The next exercise is going to be, I believe I can actually leave it on the screen here. It says, complete the following table. Do not rationalize in the denominators. It says sine x for x equals 0 degrees, 30, 45, 60, and 90 degrees. By the way, if this seems to be a little bit off the screen on the side here in Word, just scroll down a little bit down the screen and you will see the entire table. So don't worry about it. You see exactly what I see, except you might have to scroll a little bit. These values, of course, we're supposed to have memorized. So sine of 0, of course, is 0. Sine of 30 is 1/2. Sine of 45 is 1 divided by the square root of 2, or square root of 2 over 2. Either way, this one actually might be a little bit preferable, which is 0.707, and sine 60 degrees square root of 3 over 2, which is 0.866. Make sure that I have it correctly memorized. Yes, 0.866, and sine of 90 degrees is 1. Cosecant x, well, that's the reciprocal of that. So, for x equals 0 degrees, that's not defined. For cosecant of 30 degrees, that's going to be 2 over 1. For cosecant 45 degrees, that's going to be 2 divided by the square root of 2, or simply square root of 2. Let's see if I still have that in memory. Oops, I don't. Sorry about that. Square root of 2 divided by the square root of 2, of course, is square root of 2 itself. Cosecant of 60 degrees is 2 divided by the square root of 3. And cosecant of 90 degrees is 1. As we said, always the reciprocal of the sine. And again, I'm going to double check that here in the book. I have my book lying on the side while I'm recording myself. And yeah, the last ones were correct, and this one here is also correct. That's exactly what the way the solutions are listed in the book. Okay, now I'm going to scroll down here and get the next problem on the screen. It says simplify each expression. In parentheses, sine 60 degrees plus cosine 60 degrees equals something, and then the second one is sine squared 60 plus cosine squared 60 equals something. Well, let me start with the second one because I recognize that as the Pythagorean right away, so that will come out definitely to 1. You can try that on the calculator and you will see that is indeed correct. The first one, be a little bit careful. This one here, what it says in parentheses, is indeed not the Pythagorean because it lacks the squares. The squares outside the parentheses, which makes it a perfect square trinomial. So what we do here is we have to FOIL this. This is going to be sine squared of 60 plus the middle term is going to be 2 times sine 60 plus cosine, I'm sorry, not plus, but times cosine 60, and I need to borrow times from somewhere. Let's see if there it is. So there needs to be a times right there. And I think I'm going to put this on the next line, just looks a little bit better, plus, after I FOILed, cosine squared 60 degrees. And I'm going to give myself a little bit more space. Oops, didn't mean to do that. And this is here simply from FOILing, so I have first and last, and then I have the two, the inner and the outer term, which are the same on the perfect square trinomial, so we have those twice. The first here, sine squared 60 plus cosine squared 60, first and the last, are going to come out to 1 because that is the Pythagorean, and then the 2 sine 60 degrees times cosine 60 degrees is what we're supposed to have memorized. So 2 times sine 60 degrees is the square root of 3 over 2 times cosine 60 degrees, which is 0.5 or 1/2. There we go. And one more line, which is going to be 1, let's see, plus one of the 2 cancels here, and then it's going to be square root of 3 over 2. So square root of 3 over 2, or if we really wanted to calculate that out, it's going to come out to 1.866. Notice that only part of that was the Pythagorean. Again, I'm going to double check here in the book what they say, and that's what they came out. They list actually 2 plus square root of 3 over 2, but that's when you put everything on one fraction bar. It's still the same answer. So this is the way they list it in the book. Parentheses, parentheses 2, which is the same. Okay. We're actually done with this exercise, but I figured I'm going to put a little bit behind that, and the letter, I said that the second one that we did ahead of the other one is actually a Pythagorean. And then I said here, proof. Ooh, how do I prove this? Well, sine A is, of course, the opposite over the hypotenuse, so it's going to be A over C, but it says sine squared. So I'm going to use the square symbol on there. So A squared over C squared, that is sine squared A. And then we have cosine squared A, so that's going to be B over C. Let me see what we come up with. Okay. So that equals, well, we can just write this all on one fraction bar, which is going to be A squared plus B squared divided by C squared, so in parentheses, like this. Unfortunately, square there. Okay, that's the same. And now we know this is a Pythagorean triangle, so A squared plus B squared indeed is C squared, which we then divide again by C squared. So it's going to look like this. So the numerator is C squared, and C squared divided by C squared, of course, is 1. And that was the proof for that sine squared A plus cosine squared A indeed comes out to 1. Next exercise, which says find exact values, secant 30 degrees. I didn't require to have the secant of 30 degrees memorized, but I do require to have the cosine of 30 degrees memorized. The cosine of 30 degrees is the square root of 2 over 2. And I have to borrow a square root sign from somewhere. I'm sorry, did I just say that? Square root of 3 over 2 is what the cosine 30 degrees is. And the secant is the reciprocal of that. So the answer is 2 divided by square root of 3. Cosecant of 30 degrees, well, that's the reciprocal of sine 30 degrees, which is 1/2, and the reciprocal of that is simply 2. Cosecant of 60 degrees is sine 60 degrees, which is the square root of 3 over 2. So the reciprocal of that is 2 over the square root of 3. Of course, the answer for this one is the same as this one, simply because these are within the cofunction theorem. And secant 60 degrees should also come out to 2. Again, cofunction theorem with this one here, as well as cosine of 60 degrees is 1/2, the reciprocal of which is 2. Cotangent of 45 degrees, well, the tangent of 45 degrees is 1. We have that memorized. The reciprocal of that is 1. Cotangent of 30 degrees, well, that's tangent of 30 degrees. We have that memorized as 1 divided by the square root of 3. So I grab this one here, of which the inverse, of course, is square root of 3 over 1. Secant of 45 degrees, well, that's cosine of 45 degrees is square root of 2 over 2. And then square root of 2 over 2, take the reciprocal as 2 over the square root of 2, or simply the square root of 2. Cosecant of 45 degrees, well, at 45 degrees, both the sine and the cosine are meeting each other at square root of 2 over 2. So the cosecant and the cosecant are also meeting each other. So again, we have square root of 2. And just to make sure, I double check that in the book. And let's see, I do this relatively quickly. Yep, that's exactly what they come up with in the book. Okay, and I believe this is going to be the last exercise. It says, refer to the right triangle ABC, where C equal to 90 degrees. Use a calculator to find sine A, cosine A, sine B, and cosine B. So with the Pythagorean here being 5 point, A equals 3.42, C equals 5.70, and I'm figuring out B. So I'm going to take on my calculator 5.70. I think I'll open my graphing calculator, so keep those numbers in mind. Let's see, clear. So I'm going to do the square root of 5.70 squared minus, one moment, I have to arrange my notes, 3.42 squared parentheses. So B comes out to 4.56. I'm not going to return right away here to Word, but I'm going to stay on the graphing calculator because it said to use the calculator 4.56. The opposite is A, which is 3.42, and I divide that, 3.42 divide by the hypotenuse 5.70, which will be sine A, so 0.6. Cosine A is going to be the adjacent 4.56. This time I'm actually typing on the keyboard. Divide by the hypotenuse of 5.70, 0.8. And then sine A, I better make sure that I also check that with the book. Sine B is going to be, well, just the complement angle. So when I go back to Word, I show that in just a moment. I'm going to take these two values along. So this one here was, let's see, 4.56, and then this one here was 3.42 divided by 5.70, which came out to 0.6, and the other one came out to, oops, let's say, oh, 3.42. This one here is then 4.56, as we just did on the graphic calculator, and that comes out to 0.8. And this one here, sine B, then is the complement to cosine A, so this one comes out to 0.8, and cosine B is the complement to sine A, which comes out to 0.6. And with that, I conclude the problem section on 2.1.